Okay, here's a look at what we'll be doing today. We want to get the AI character to follow us and traverse kind of like we can. So let's get straight into it. Let's open up the sandbox AI character. So go ahead and go to your blueprints folder, find the sandbox AI character we were working with in the previous video, and go ahead and open it up. And basically we want to try to recreate the AI move to node. Since we have to use the add movement input node instead of this node, we're going to just kind of add some things to kind of give us the same idea, like the acceptance radius and stop on overlap, or choose if it was successful, things like that. We're not going to do all of that in this video, but we want to kind of give some custom ability to the add movement input. Okay, let's start by adding a new function. So find the function over construction script and hit the plus sign. And we'll rename that to find path points. And we want to add an input to this, a vector. And we'll go ahead and rename that to target location. And we want to, since we have to use the navigation grid, we have to find a path using the navigation AI. So that's what we're going to do. We want to create another variable and call it point index and make that an integer. We're going to set it to 1. So this will be the next index, the second index, because it starts at 0. And now we want to find path to location synchronously. And this will find a path to our target location. So we get our location, or the AI's location, and drag that into path start. And then we take the target location and we put that into the path end. And clean up the grid a little bit. And from the return value, we want to drag that out and search for path points, or get path points. And we want to promote that array to a variable. We'll name it path points. Okay, and we'll drag that new variable out, and we'll get a copy of that. And we'll drag our point index that we set to 1, and we'll connect that to that. So we're getting index 1 in this array, which is the second index, but its name is index 1. And we'll make a new variable and call it next target location and make that a vector. Make it a vector, delete that if you followed along. All right. Delete it. There you go. There you go. Okay. Set it. And so the path point at index 1 is going to be the next target location. Okay, and we'll make another variable and we'll call it speed. And we'll make that a float. This will be the speed of the applied to the movement input. We'll go ahead and make that 0.95 for now. Go make another variable and call it start movement, and we'll make this a Boolean. Drag that out, and then tick it to be true. And then compile and save. And here's a better look at the whole thing. Okay, now we want to make another function for direction to the target. So we'll name this direction to target. We want to get actor location. We want to get unit direction vector. Now we want to get the next target location. And go ahead and split that. And split the 2 on the get unit direction vector as well. And plug the X and Y from the new target location into the X and Y to the 2 in the get unit direction vector. And we want to get another actor location, split that, and then grab the Z only from that and plug that into direction vector, because we want the Z from the AI always, in case, you know, the player character is jumping or the location is moving to somewhere where the Z can't be reached. Okay, and then do a return node and plug the return value into the return node and name that target direction. Or, you know, let's name it direction to target. Okay. Compile and save. All right, make another function, and we're going to have this be called arrive at location. This is going to check if we're within a certain distance of the target. You know, and if we are, we'll send out a return saying, you know, whether or not we'll send out a Boolean saying whether or not have arrived at the location. So we want to add a location input, which will be a vector, and we want to add a radius, which will be a float. Okay. And we want to get actor location. We want to get the location from this. So if you search for location and go all the way to the end, it will be the location for this function. And we want to get another actor location and get distance vector. And we'll split that and split that. Plug the Z from that in there, and then split the location, and then plug the X and Y from the location into the X and Y to the distance vector. And we want to see if that's less than or equal to the radius, which will be whatever value you want. You know, I usually put it around 250 or so, just so it doesn't crowd the player character. Connect them. Connect to the branch, and then off the true node, add a return. Actually, we don't need this branch. We just want to delete the branch and drag this directly into the return. the result of the radius greater than or equal to. And we'll name that arrive. All right. So if it's less than or equal to the radius, then we have arrived. If it's not, then we have not arrived. Okay. So let's go ahead and set up the node this way. Put the arrive at location after the add movement input. Okay. And we want to plug the next target location into the arrive at location. And then coming out of the arrive at location, we want to have a branch. Okay, and this is this old code. We're gonna remove this. I don't think we're not going to use this. Okay. So now we're going to do another function, and we'll call it find next path point. And so what we want to do in this is we want to get the point index and increment it by 1, because we want to get the next path point. So we're going to look at the index, and then the next index is going to show us the next path point. All right, and we want to check the length of our path points. And we want to see if the index is equal to or greater than the length, because if it is, that means that we've reached the end of our path, because there are only X amount of path points for the distance of the path. Okay, so we'll check if it's greater than or equal to that into a branch. And if it is greater than or equal to, we will stop the movement. So we'll pull out the start movement node and uncheck it. We'll set it to false. But if it's false, if we haven't reached the point, if we haven't gotten to the end point of our path, then we want to set the next target location to this point index point. So get a copy of our path points and grab the point index. Plug that in there and then drag that out and set that to the next target location. Okay, so if we were at path point 2 and we want to get to point 3, we got to get index 3. All right, so we're getting the next index, the next path, and we're setting the next target to that path, or to that location. Okay, so now what we want to do is create a custom event and call it find path to target. Custom event. And we want to add an input of a vector, and we'll just call it location. Or target location. And then we want to find path points and set this target location to the endpoint for the path. So we're finding path points to that target location. Okay, we'll go ahead and delete this. We don't need that anymore. All right, now from this, okay, we're going to create a new variable from this direction to target. We're just going to promote that to a variable instead. Just rename that direction to target. Or we already have that as a name. We'll call it, what will we call it? We will call it target's direction. All right. We'll set that. From the true, go into that, and then from that, go into the add movement input, and then drag out the target direction that we just promoted to a variable, drag that variable out, and then put that into the world direction. Okay. Compile and save. All right. And now from the false, we want to create a new variable first, and we'll call it follow player. And we want to drag out from the false to a branch, and we want to check if we're following the player. Okay. And if we're not following the player, we're not going to do anything. If we are following the player, then we will arrive at location. We want to pull out that function, plug that into the true, and then pull out a branch from the arrive. And if we have not arrived, then we want to call that custom event we just made, find path to target. Okay? And so for this location, in the target location, we're going to make a new function to find the player's location. Okay, we need a new function. We'll call this get follow target location. This is to find the player character. So right click, get player character, drag off that and get actor location. From the player character, we want to drag off of that and get a capsule component. And then from the capsule component, we want to get scaled capsule half height. We want to split the struct pin of the get after location, and from the return Z, we want to subtract, and we want to plug the scaled capsule half height into that subtraction value, and then we want to add 7 to that to get it off of the floor. So it's just a little bit off the floor. We want to make a vector, and we want to plug the X and Y from the actor location into the vector. We want to drag the Z from the scaled capsule half height subtraction and addition into there. All right, we want to drag off that return value and add to that. And what we want to add is we want to copy and paste player character actor location, recombine the struct pin, and we want to duplicate that actor location as well, and we want to get unit direction vector. Okay, we want to get the unit direction from the player to the AI. Okay, and we want to drag off of that and multiply that by a double float. So right click on the bottom pin and choose float and choose 200, and then drag that into the bottom pin for the addition of that vector. Okay, so you're adding that little 200 unit bubble to the actor location. Okay, and we want to return that as a target follow target location. So plug that into the return node, hook the return node up to the start node, and then compile and save. Okay. Sorry if that one went a little quick. Here's the nodes so you can get a better look at them. Go ahead and shrink that down a little bit. Get a better look at everything there. And that 200, that just kind of gives you more space between you and the AI following you. All right, so now drag that out. We want to make that a pure function, actually. And then we want to drag that into the location there. And then duplicate that and plug it into the target location there. Okay. All right, now go back into this. Delete where we had the start movement checked to false or unchecked. We want to create a new function, just have it called stop movement. And we'll set the speed to 0. We'll make start movement false. And the target direction, we will set that as the actor's forward vector. No, delete that. Yes, delete that, and yes, actor get actor forward vector, and plug that into the target's direction and set that. Compile and save. And now in the find next path point, when it's true, if the length is greater than or equal to the point index, stop movement because it's reached the end of its path. Okay. So, oh yes, go in here and change this radius to 250. I never did that. And then change this one where the next target location is plugged into the arrive at location. Change that radius to 100. Okay. Compile and save. Now open up your sandbox character. And let's drag out the AI sandbox reference. And we want to check if that's valid. If it's valid, we will get follow player and not Boolean. Okay, so we want to see if the player is not being followed. And then we want to set follow player. Okay, so we want to get follow player, and whatever it is not, we want to set it to. Okay, so if it's not following a player, we want to set to following the player. If it's following the player, we want to set it to not following the player. And then we want to drag off from that not and put it into a branch. And in that branch, if it's true, if the follow player is not being followed, then we want to start movement. Okay, so follow player is not being followed. If that's true, set it to start movement. So that will start following. Okay, let's test it. All right, so now he's going around. Okay. So now I want to add the ability to traverse. Okay, so let's add some things to our functions to help us traverse. So from the inside our find path points, from the find path to location synchronously, from the return value, pull that off and look for get path cost. And we want to pull that out, and we want to promote that return value to a variable, and we'll call that like current path cost. And as far as I can tell, the path cost is somewhat equal to the distance of the path it's currently on. Okay, and also from the find path to location secretly, pull off that and check if it's valid under navigation. Check is valid, and pull a branch off of that and plug that in. And if it's false, then we want to stop movement, because if the path isn't valid, the AI starts to do some wonky things, like maybe walk back to the map origin or things like that. So stop movement will trigger it to kind of find new path points again. Okay, so compile and save, and then go back to the arrive at location function. And now inside of there, we want to pull out this current path cost variable that we just created, and we want to multiply that by like 1.2 or something like that. And we want to see if that's greater than or equal to this distance that we're trying to find in this arrive at location. Because, and from that, if it's true, if it's false, just plug it in to the return node. But if it's true, we want to try a traversal action. But first, we want to create a branch, and we want to check if traversal action is already being done. So pull a branch off for that. And if traversal action is already being done, then just plug that into the return node from the true. But if it's false, if a traversal action is not being done, we want to try one. So go into the sandbox character, and over by jump, it tries a traversal action anytime you jump. So copy and paste that along with the function it has plugging into its trace forward distance. And then if we're not doing a traversal action from the false mode, we want to then try a traversal action. So they'll try to jump over a wall, traverse the wall or something like that. Okay? And from what I can tell, basically we want to, if the current path is bigger than it should be, is kind of what we're checking for here. If the path is bigger than it should be, then maybe there's a wall in our way, so maybe we'll try to traverse it. And that's the theory behind that. Okay? So in the event tick in the beginning, we want to check if we're doing a traversal action, because if we are, we don't want to keep creating path points and things like that, because the AI starts to get wonky. So if we are traversing, well, if we're not traversing, if it's false, we just plug it into the branch and go away with the start movement. But if we are traversing, we want to clear the path points. So pull out the path points variable and clear that. And then we want to also check if we're falling. So, okay, if we're doing a traversal action or if we're falling, because if we traverse something and we start walking on like a higher level plane, then when we walk back down and fall back down to the normal plane, we want to clear the paths and stuff like that again, because it starts getting wonky. So if you're falling or if you're doing a traversal action, we'll clear the path points, we'll stop movement, and then we'll set next target location, drag that out, next target location, and we'll set that as the get follow target location. We'll pull that function out and we'll grab that location. We'll have that be the next target location. So when we're traversing, we've stopped movement, we've cleared our path, and now next location will be wherever the player's at. That's where the target flow location is. Okay, so let's try it out. Oh, first off, I kind of take it for granted. The default map already has the nav mesh volume in the map, and that's what allows AI to move. So for whatever reason, if you're in a map that's not using that, you want to add a nav mesh volume into your map. Okay, but if you already have that, what we want to do is we want to add a Nav Link Proxy, and we want to add 2 of these Nav Link Proxy, because you see, if the AI gets on top of this block, he's not going to be able to get down unless we have this. I mean, he can get down sometimes, but this will allow him to get down regularly. So we want to drag that down. We kind of just want to make sure the diamonds are kind of on the surface. And then we want to make sure some smart link is relevant. So activate that. And then we want to copy the left and right links. We want to copy them from the simple, and we want to paste them on the smart link. So you copy, and then we want them only to go from left to right. So you can only go from the top of the surface to the bottom of the surface. That way the AI is not including the top of this in his paths, okay? Because if you have it go both ways, when you're checking for a path, he'll include that then. So, but if he only can go it from when he's up there, they won't be added to the path, okay? So now rotate that 180 degrees, and we want to get the diamonds on the surface, and then we want to make sure the smart link is relevant. Okay, and then we want to copy the left, and we want to copy the right and paste it to the left and paste it to the, okay, so left goes to start, right goes to end. Okay, so go ahead and go test it. There you go. Hopefully it's working. If you guys have any questions, let me know. I'm still pretty new to tutorials, so if it's a little confusing or anything, just feel free to ask me any questions in the comments. Thanks again for stopping by.